Yeah, hello to this video. Today I'm at the Dirkshof, a community-owned wind farm with 300 megawatts of electrical power. This is really impressive. And I'm standing here with Henning Boise. Very happy to be here. Thank you very much for inviting us here. And please give us a short introduction what you are doing here at Dirkshof and at this site.
Yeah, thank you for the introduction. Dirkshof is a company that operates and develops wind projects, and we're standing here right in the middle of one of the biggest wind farms in Germany, I think, and also community owned, which is also a benefit. This area is the substation, which is necessary to collect all the power from all these wind turbines and transform the voltage to something more grid compliant, I would say. The wind farm consists of 88 turbines, which total to 300 megawatts, which is quite a lot. Then we have a substation, and also, which you can see there's also a quite new battery storage, which is used for energy trading, but also grid stability services. So we combine here different kinds of energy production and also stability services, and more projects to come. So it's quite exciting to have the ability or the chance to work here.
Yeah, really great to be here. So let's have a closer look at the station and go over there maybe a bit. Okay, so here we see the whole overview. Could you explain this, just maybe going step by step from the wind turbine to the different households, what is happening?
Yeah, this is the overview of the wind farm, which is called Windpark in the far northwest of Germany. We have 88 turbines here, and if you have so many turbines, the grid operator requires or asks you usually also to provide a substation. And this is where we are here. This is the substation in the middle, and on the left, the turbines are attached to it with many different grid lines on 20,000 volt level. And what the substation does is just convert the 20,000 volt to 110,000 volt, which goes through a different grid line to the next village, which is 7 kilometers away from here, which is this one here. And that one does two things. On the one side, it puts the voltage down again to supply houses or industry with electricity, but it also increases the voltage once again for transmission to Hamburg, for example. And here on the bottom, we see also several other ways to use the electricity. The battery storage exists already, but we're also working on other projects as like a hydrogen production and fuel station, which also results to usage of heat, basically, to increase the total efficiency.
So what battery storage capacity do you have here at this site?
Currently it's 16 megawatt hours installed with 8 megawatt of power, which is quite a big battery. For example, you could power one house for several years just from this battery, so it's quite big.
So what do we see here now?
Yeah, this is the substation owned by the wind farm. It's 4 big transformers which transform 20 kilovolt of electrical energy up to 110 kilovolt. In total, it's 240 megawatt of power capacity, or 80 MVA for each transformer. And of course, we can see there also the auxiliary equipment, everything that's necessary to operate these transformers.
Okay, and over there we also have the battery storage. That's what we can hear at the moment, right?
Yes, that's quite a new topic in Germany at the moment, because big batteries are now quite affordable. And this storage there, it's 16 megawatt hours of capacity and 8 megawatt power. And we use it for energy trading, but also for grid stability services. So we draw power from the grid if the net frequency is too high, for example, or energy is cheap, and the other way around. So that's what we do here. And what you can hear here, it's just the cooling, because the efficiency is of course not 100%.
Yeah.
It's lower than that, and there's some heat that of course needs to be taken away.
And regarding the electricity price zones, so in Germany it's a big topic that we have one joint electricity price zone at the moment. Well, what is your opinion? Would it be easier if it is split, the price zone, or?
The price zones are related to the grid fees, which don't really apply to this. We're looking at the energy prices. There's in Leipzig a daily auction, or also every 50 minutes auctions. There are different kinds of trading mechanisms, and there a sub-supplier just trades the energy, buys and sells, and tries to use or use the battery as optimized as possible.
What is your prediction for the future? Will we see more of the usage of the electricity right here? Because if we produce more in the north, but in general, we hopefully at least don't ramp up our usage so much for the households, for the cities. Can we then have an opportunity to do other things like hydrogen, for example, generation here in this area?
Yeah, that's a big challenge. The politicians mainly are facing because the big power lines that are built on planned and will be finished in the mid-30s, these are already too small. So we need other kinds of or other ways to use all the green energy that we produce in northern Germany. And there, for example, hydrogen is a big thing, which I think will make sense in the future. But also batteries to store the energy when there's an excess and use it in the evening, or when there's less sun, or But you need a mix of all kinds of storages and applications to make the whole thing work properly.
Okay, wow, we're here in the control center now. It's really impressive what we can all see on the screens. Could you explain us a bit more what this all is?
Yeah, this is an overview basically of all wind farms which we operate, take care of. And this is the technical supervision department, or how you want to call it. And we make sure that all turbines operate as they should operate. And also there's maintenance, we talk to technicians, we schedule our own inspections, and basically make sure that the technical availability for all turbines is as good as possible.
Okay, and what is here in more detail? I see we have the weather data here on this screen, and these are the individual installations we can see. And what do we see on this screen over here?
Yeah, you're correct, there are different screens. The wind forecast is interesting. For example, if maintenance is scheduled for the following day, then we check whether there's high wind or low wind. And if there's high wind, we try to reschedule the maintenance to lower windy wind days. And there are some screens that change sometimes. This, for example, is a live overview of some turbines. So on all other maps, we see average data of the last 10 minutes. And this is really live data with 1 hertz. So every second we get new data, and there we really can see the live wind speed, the power and availability, the status with the status codes here, and also the total production.
In which time frame this is for this year?
That's I think from installation, from the beginning. So it's here in average about 20,000 megawatt hours. And these turbines were installed 2.5 years ago. And also we have limited access to the turbines, so we could, for example, turn them off or switch them off if we wanted to. But that's usually not the case. And further on the left, we have some information about the substation, which we also have installed in this wind farm. And there you can see the total power at each cable line and the status of that.
So regarding the stability of the overall electricity net, it's quite a challenge to have a lot of regenerable energy sources in terms of maintaining the correct net frequency, the correct power, basically. So how does that affect you? I mean, you just push out, or you get certain regulations how you have to do it, when you have to do it? How does that work?
You're correct. It's a big challenge for the general net or grid here. We basically operate the turbines how we want them, but the grid operator has the ability to switch off turbines in case the net frequency is too high, for example. So there's some ways, and it's also done on a regular basis, that we're getting switched off here to stabilize the grid when it's windy and sunny at the same time. And Sunday, where the consumption is low, we see that quite often.
So do you monitor the net frequency, for example, yourself, or you just get them that info, or they just turn off
They
certain
just turn it
turbines?
off.
So there's a connection basically directly of this control center to the provider control center.
So we don't have any impact on their decision or influence there. And we also don't monitor the net frequency. It's their responsibility to make sure it's within the limits.
And regarding what you're monitoring, you were talking about monitoring with different sensors, the different wind turbines. So what are the typical error cases that you observe here and where something has to be done?
It's usually, in general, basically all turbines here are covered by a service contract of the manufacturer usually. And they guarantee a technical availability of, for example, 97, 98%. And we just make sure that they do their job. So we control them and tell them, here, there might be an issue. Maybe you want to check that. And of course, there's maintenance is often a reason why a turbine is switched off, but that's planned, so scheduled. Non-scheduled events or any kinds of faults, as grid problems or electronic problems or pitch failure or whatever. It's a complex machine, so there's many parts.
So each of these here is an individual wind turbine, or what do we see here on the screen?
Yes, correct. Each square is for one wind turbine. We see the serial number on top. Then there's the power output and the wind speed. And depending on the wind speed and the power, we can estimate whether the turbine is operating normally or not. And if it's not operating normally, the color changes. So red is typically the color for evil or not correct, and green is good. And there are some different states as well. So, for example, for maintenance or for communication problems. So but only for the basic overview. There's software that goes into a lot more detail on top of that.
So do we have good wind conditions at the moment for generating wind power?
Yes, today is quite good. We see here different wind speeds from 8.1 meter per second or 6.6. It's not everywhere the same, as someone might assume, because there are shadowing effects. So if one turbine is placed behind another turbine, the one in the back gets less wind, for example. So we see quite different numbers here.
Okay, so what is the direction of the wind? I guess this is north-south orientation here, is that correct? And so which wind direction do we have at the moment?
The general wind direction is shown with this arrow.
Okay, I see.
And this also is the main wind direction. So it's typically west to southwest here, because we are very close to the North Sea. So the wind is not really disturbed over the water, and we get high wind speeds usually because of that.
And so regarding the wind speed and the shadowing effects you were talking about, when you place the installations, I mean, do you place it such that for a certain wind direction it is best, and then if the wind direction changes, you have shadowing effects, or how does that work?
It's part of the planning. There are many factors to be considered within the planning. Also, which property do you have available, and are there restrictions regarding shadows or distances to population, and also biological protected areas or something. But if we would be allowed to plan or place them how we really would like to then put them, then this would be the main factor.
Okay. And so what is the distance here between the different installations in the array?
The rule of thumb is usually a minimum of 2 to 2.5 times the diameter of the rotor. So it would be 250, 300 meters between each turbine as minimum.
Okay, so if you're now going, after you were saying after 10 years, you maybe go to a new generation of larger power, so larger size turbines, do you then change the array placing also, that means?
That's part of the challenge.
Okay.
The optimum would be to just put it on the same spot as before, but as the rotor diameter increases, also the turbulences behind the rotor increase. So there's a lot of simulation analysis going on if it's possible or not. But yeah, that would be the goal.
But that means for the given area that you have, you can place less if it's higher power? Is that?
Usually, yes. So we sometimes dismantle 2 smaller turbines and just install one instead of them, which in the end makes more energy than the older 2 ones. But yes, that's basically how it works.
Okay. And so regarding the foundation of the different installations, so how much foundation is needed for a certain size, or how does that work? I guess it depends on the soil also that you have.
Yeah.
And
correct. The first thing you have to do is soil investigation, so drillings, and then there's engineers to write a report and also then determine the kind of foundation you have to build. There are piled foundations and gravity foundations. We're usually aiming for gravity foundations because they're easier and cheaper to build.
what does it mean, a gravity foundation?
It's basically like a plate. It looks like a plate out of concrete.
Okay.
It's just heavy weight, which is 15 meters in diameter and weighs about 600, 700, 800 tons, depending on the turbine size. Yeah.
Okay, and that is your preferred way of going.
Because once you have to use piles, everything becomes way more expensive.
So what is a pile? What does that mean?
A pile is a big concrete stick, basically, which you ram into the ground, 25 or 30 meters, depending on what the expert report says. And not just one, but 20, 30, 40. So, and that's quite expensive to do.
So regarding the whole procedure, if you want to set up a new installation, how long does it take to get the permission? How much is the construction site? How much time does it take to get it running really? What is kind of the time frame of this process?
It really depends. In Germany, it's not unusual to have 3 to 5 years or even more, depending on which issues you face on your way to get the permission or even after that. In other countries, it's sometimes a lot easier. So it depends. That's the answer. But several years.
So that's the permissions mainly, or in the construction itself? How long does that take?
The construction is quite fast. You need a few weeks to put down the foundation. Then there's of course some cables to put in the ground. The foundation needs to dry about 30 days. And then the installation of the actual turbine is 2-3 days plus 10 days commissioning maybe. So that's quite fast compared to everything else.
So how did you come to the Dirkshof? Are you from this region here?
I'm from Hamburg actually, and I studied business and engineering at Brunswick. I think I finished in 2014, 13 something, and started working at a turbine manufacturer also in Hamburg. And this made me like, or created this enjoyment of this business, this fascination of renewable energy, wind turbines especially. And after that company went bankrupt, I moved here because in this area are many exciting companies who do such things, renewable energies. And now Dirkshof has 30 employees roughly. And we have a lot of work, and we're continuously also looking for new stuff in all areas, basically.
So what different disciplines are working here at Dirkshof? What are you looking for also?
Very interesting are people who are into electronics, engineering in general. But yeah, we have lots of things to do with electricity, obviously. So we like to hire people who know things in that area, but also people who are into all these permissions, regulations in Germany in order to develop new sites, new projects. That's basically what we are looking for.
Yeah, so at Kiel University, as a full university, we have engineering, but we also have economics, engineering, also, of course, just economics, law, many different disciplines available. So it's very good to
Yeah, there's a place for almost everyone, I think.
Yeah.
And we also accept or like to have students at our office to write their master's or bachelor thesis or just work there. And that's...
Yeah, so that was a very exciting day today. Thank you very much for meeting us here. I hope to see you again in the future soon, and a very exciting project you have going on here. So best of luck, of course, and I hope we will manage to get renewable energies here up to a large level in Schleswig-Holstein and in the world. Thank you very much.
Thank you.